Hello, welcome to this channel. Now, the question I have here is on velocity time graph. We are given a velocity time graph here. And the question says, from the velocity time graph below, find A, the acceleration, B, the retardation, C, the total distance covered, D, the average speed of the motion. Now, for us to handle this, we have to look at the graph critically. Don't forget, this is the acceleration line. The body started from 0. That means it started from rest. So this is the acceleration line. This line is for the constant velocity, maintaining constant velocity. And then this line is the retardation line. So now, I would like to solve it from here. And I'll say question A. For us to find the acceleration, the formula for acceleration is given to us as v minus u all over t. So this is the formula for acceleration. So with this formula, we can now analyze the velocity, which is the final velocity. V is the final velocity, u is the initial velocity, and t is the time taken to accelerate. Now, from the graph, we have to obtain the value of u, v, and t. So the body moves from here to this point. This is the acceleration part. So we are only going to analyze this part as the acceleration part of the graph. So it started from rest, which is 0, and then increases in velocity up to 15. Don't forget, this level is 15. So when we are reading the velocity, we read only the vertical portion of the graph. That's the vertical axis. So we have to read the beginning of this acceleration line, which is 0, and that will give us u as 0. So u is 0 because the initial velocity is 0. And then it moved up to the highest velocity reached, which is 15. So the final velocity reached is 15. So we can now substitute the values here. So the final velocity reached by the body, which is 15, that is the value that we have here, is given to us as the final velocity v. And then minus the initial velocity, which is the beginning of this line. The beginning of this line is 0. So this is 0 and this is 15. So the beginning of this line is at 0, which is the initial velocity of the body. So 15 minus 0. So v is 15, u is 0. And then all over the time taken to accelerate. So it accelerated from here to this point. But when we are reading the time, we read the horizontal axis. Don't forget, when you are reading velocity, you read the vertical axis. When you are reading the time, you read the horizontal axis. So the time taken to accelerate, that is the time from here to here, is this value here, which is from 0 to 6. Don't forget, the time also started from 0 and then to 6. So the time it takes to accelerate, that is to reach this highest point of acceleration, is 6 seconds. So the time is 6 seconds. So from there, we can continue by saying 15 minus 0 is 15, all divided by 6. And that will give us the value of the acceleration as 15 divided by 6 will simply give us 2.5. And the unit of acceleration is meter per second square. So this is the acceleration of the motion. Now, let's move to retardation. That is the B part of the question, retardation. Now, we should not forget that acceleration and retardation have the same formula, except that acceleration is negative retardation, or retardation is negative acceleration. So now, I'm going to also write the formula for retardation, which is also A. Don't forget, don't use the letter R. A for accelerate, for retardation as well. Then it is V minus U all over T. Some people like using U minus T, but no, it is the same formula, but you just have to get the U and the V accurately, and that will help you to get your answer. So now, This is from the graph, this is the retardation section. This is the retardation section. So the body was at this level of 15 meters per second. Don't forget, this level is at 15. So, which is this 15 here. So, at level 15 meters per second, the body started slowing down. Retardation means the area of slowing down. Acceleration means increasing in the speed. So, it started slowing down from 15 meters per second and then finally came to this point. Now, this point is not 18. Don't forget, in reading velocity, we read only the vertical axis. So, we are reading this point, which is 0. Don't forget, at this point, when reading the vertical axis at this point is 0. And the vertical axis at this point is 15. So, don't make the mistake of reading horizontal axis. When you are taking velocity, you read the vertical axis only. So, at this point, it was at 15, and then it slowed down until it got to 0. So, that is from 15, it got to 0, which is this retardation section. So, from there, we can say that the initial velocity is 15 and the final velocity is 0. This is where you have to be very careful. It started slowing down from 15 until it stopped at 0. So the initial, that's the beginning, is 15 and the final is 0. So here we can say the final velocity, which is when it finally stopped, is 0 minus the initial velocity when it started retardation is 15. So minus 15. Then all over the time taken to retardate, the time for retardation. So to get this time from here to here, that is moving from here to this point. So now you read horizontal axis, time horizontal axis. So the time from here to here is simply 18 minus 14, which is 4. So it took 4 seconds to move from here to here. And that is the 4 seconds that we can see here. That is 18 minus 14. And that is 4 seconds. So we can continue from the calculation and say it is equal to 0 minus 15 is negative 15 all over 4. And then negative 15 divided by 4, you agree with me that that will give us retardation as negative 15 divided by 4 is minus 3.75. So the retardation is negative 3.75. So this is the retardation. That's why I said from the beginning that retardation is negative acceleration. That's why we got the negative sign here. But in conclusion, to conclude, you can finally say therefore A is equal to 3.75 meter per second square. In conclusion, you can remove the negative sign when you are concluding. So this is the retardation. Now, don't forget, after that, the question says we should find the question C, the total distance covered. The total distance covered. So for us to find the total distance covered, we have to calculate question C now. We have to calculate the area under the graph formed in the question. The area under the graph. So now, what is the shape of this graph? The shape of this graph is a trapezium. So for us to calculate the distance covered, that is the total distance covered, it has to be the area of the shape, which is the area of the trapezium. Area of trapezium is half, mathematically now, in mathematics, I want to believe you know the area of a trapezium, half multiplied by the top distance added to the base distance multiplied by the height. So this is the formula for the area of a trapezium. Half sum of parallel side, which is A plus B, multiplied by the height. So now let's put in the values. Now, this is the top part A. So what is the value of A? The value of A can be read from the bottom part. Don't forget, this part is also equal to this. So 14 minus 6 will give us A as 8. So this point is 8. That is 14 minus 6 is 8. So this point is 8. which is also equal to this point A. And then the B part of the question is the full length of this base, starting from 0 to the very last value here. So this last value here is always the base B. Whatever last number you have here is the base B. So we now have A and B, and don't forget the height of the trapezium. That's the distance between these two parallel sides. And that height is 15. So this is the height of the trapezium. That is this 15. So substituting values now, I have 1 over 2, brackets open, A we obtain as 8, plus B that we obtain as 18, all multiplied by the height, which is 15. So we can now walk further and say that half multiplied by 8 plus 18 is going to give us 26 multiplied by 15. So if we multiply 26 by 15 and then we divide our value by 2, we are going to get the area of the shape, which is the distance. So 26 multiplied by 15 all divided by 2 is going to give us 195. And that is distance, which is meter. So the unit of distance is meter. So this is the distance, the total distance covered by the body or in the motion. So that is how to calculate the distance. And then finally, don't forget, we have the last question for us there, which is quite simple. The last one says the average speed of the motion. Now, for us to calculate average speed, it is simple. Average speed, this question D now, average speed. You agree with me that the formula for average speed is total distance. Total distance all divided by the total time. So this is the formula for average speed. Now, the total distance we just calculated now as 195. That is the total distance, 195. And what's the total time? From our graph there, we can see the total time. The total time is this very last value here, 18. So we have 6 added to 8 added to 4. So everything that you see in the question, all the time given to us in the question, add up finally to 18. So the total time is always this last number that you have here, which is 18. So the total time is 18. So we can now say divided by 18. And when we divide 195 by 18, it's going to give us an average speed of 10.8. We can say 10.83. So the formula for average speed is, the unit for average speed is meter per seconds. And so this is the average speed of the motion. Hope you enjoyed this video on velocity time graph. I want to believe if you have any question on this, you can put it in the comment section below. Please don't forget to like and share this video so that others can learn from it. Thank you for watching, and I'll see you in my next video.